Section 5.2 is all about factoring trinomials. So we're going to use the skills we learned before where we have to factor out the GCF, and we're going to factor out, we're going to be able to factor by grouping, but I only have 3 terms, so we're going to have to do something a little special. So friendly reminder, trinomials are 2-degree polynomials of the form ax squared plus bx plus c. And what we're going to do in order to factor trinomials is we're going to find, what we want to do is multiply a by c, and then we want to find the factors of ac that add up to b, and if no such factors exist, our trinomial is prime. We then write our middle term bx as the sum or difference of the 2 factors that we found in step 2, and we factor by grouping. Okay, what does this mean? Well, first I want us to practice our new mantra. We want to find the factors of AC that add up to B. We're going to find the factors of AC that add up to B. I like to start with every trinomial by labeling my ABCs. In this case, A equals 1, B is 8, and C is 12. So AC is 1 times 12, which is 12. So I need to find some factors of 12 that add up to 8. Now you may already know the answer, but I'm going to write all the factors of 12, right? I could have 1 and 12, 2 and 6, 3 and 4. I could also have -1 and -12 because 2 negatives make a positive, -2 and -6, and -3 and -4. So of these, the only factors that would add up to B, which is 8, would be 2 and 6 because 2 plus 6 is 8. What I'm doing is I'm using these factors to pull apart my middle term in a way that will make this trinomial factor. So I've got x squared plus 2x plus 6x plus 12. And it doesn't matter if I wrote 6x first or 2x first. Remember, multiplication is commutative, so we could switch it around. It's also associative, but... All right, now I'm going to factor by grouping. The greatest factor of x squared and 2x is x. The greatest factor of 6x and 12 is 6. Now, I know I did this correctly because both of these are the same. Actually, I wrote 12 and it should be 2, but I would get x plus 2 and x plus 2 because both of those are the same. I then collect my greatest common factors and what they both had in common. Let's go ahead and check our answer. We check our answers after factoring by grouping by foiling. So I get x times x, which is x squared, x times 2, which is 2x, 6 times x, which is 6x, and 6 times 2, which is 12. So that gives me x squared plus 8x plus 12, which is what I had before, so I did this correctly. Next, I have x squared plus 2x minus 35. So I need to find the factors of AC that add up to B. In this case, A is 1, B is 2, and C is -35. So AC is 1 times -35, which is -35. So I need to find some factors of -35 that add up to B, which is 2. So one of my values is going to be positive, one of my factors is going to be positive, and the other factor is going to be negative. So I could have 5 times -7. Well, that adds up to -2. What about -7 positive 7 times -5? Well, that adds up to positive 2, right? 7 plus a -5 is 2. So I'm going to rewrite my middle term. Wow, I mumbled that. We're going to rewrite our middle term as 7x minus 5x, because we use the 2 factors, minus 35. And now I factor by grouping. The greatest factor of x squared and 7x is x. The greatest factor of -5x and -35 is -5. So my greatest common factors are x minus 5 times x plus 7. Now let's notice something really quick. So I said it's going to factor into a 7 and a -5, and then over here I have a -5 and a 7. Let's check the previous page. I said it was going to factor into a 2 and a 6, and here I have x plus 6 and x plus 2. This is a special rule, And it only works when a equals 1. Okay, so if a doesn't equal 1, don't even try it. And you can always, again, find the factors of AC that add up to b. I'd recommend always doing this. Don't take shortcuts, especially in mathematics. So let's take x squared plus 6x plus 7. So a is 1, b is 6, c is 7. So I need to find some factors of AC that add up to b. Well, what are some factors of 7? 7's a prime number, right? It's only got factors are 1 in itself. Do either of these add up to 6? No, here we've got 8. Here we have negative 8. So this is an example of a prime polynomial. As of right now, we cannot factor it, but in future chapters we will, but not this chapter. So this is prime. All right, let's go ahead and label our ABCs for this first example here. A is 1, B is 6A, and C is negative 16A squared. So I need to find some factors of AC, which is negative 16A squared, that add up to B, which is 6A. Okay, so let's go ahead and look at what are some factors of negative 16 that add up to 6. Well, we have negative 2 and 8, right? Negative 2 times 8 gives me negative 16. Add them together, I get 6. If I put an A after each of these guys, and I would get negative 16A squared. So I can pull apart that middle term. So I've got negative 2AX and 8AX. And now I say we can factor by grouping. So what's the greatest common factor of x squared minus 2AX? Well, that's going to be a x. What's the greatest common factor of 8AX and negative 16A squared? That's going to be 8A. So I collect my greatest common factors. I've got x plus 8A times x minus 2A. Next, here I have 12x squared minus 5x minus 2. So A is 12, B is negative 5, and C is negative 2. So AC in this case is going to be 12 times negative 2, so I have negative 24. So I need to find some factors of negative 24 that add up to negative 5. So I've got negative 2 times 12. Okay, that's not quite right. How about negative 4 times 6? Oops. Okay, how about negative 8 times 3? Negative 8 times 3 is negative 24. Negative 8 plus 3 is negative 5. Awesome. So I have 12x squared minus 8x plus 3x equals negative 2. And now we can factor by grouping. The greatest common factor of 12x squared and negative 8x is going to be a 4x. The greatest, there's not a 2 there. The greatest common factor of 3x minus 2x is just going to be 1. I collect my greatest common factors, so I have 4x plus 1 times 3x minus 2. Okay, let's go ahead and do another example. This is in quadratic type form, okay? Because instead of having x squared and x, it's got y to the fourth and y squared, and it'll follow the same rule. So let's say I have a equals 6, b equals 7, and c equals negative 20. AC equals negative 120, and I need to find some factors of negative 120 that add up to positive 7. So how about 10 and negative 12? That's a nope. 120 is also divisible by 6. Well, yeah, because I had 6 times negative 20. It's also going to be divisible by, we already did 12. Is it divisible by 8? Let's find out. It is. That gives me negative 8 times 15. Ding, ding, ding. Negative 8 plus 15 adds up to 7. So I have 6y to the fourth minus 8y squared plus 15y squared minus 20. So now I can factor by grouping. The greatest common factor of 6y to the fourth and 8y squared is 2y squared. The greatest common factor of 15y squared and negative 20 is 5. I collect my greatest common factors. And there you have it. In some cases, we're going to have to factor completely, and that means we have to pull out the greatest common factor before we can factor accordingly. So what's the greatest common factor of 16, 24, and 16? Well, that's going to be 8, because 16 doesn't go into 24. The greatest common factor of y cubed, y squared, and y is just y. So that gives me 8y times 2y squared plus 3y minus 2. And now I can factor this by finding the factors of AC that add up to B. Well, AC in this case is 2 times negative 2, which is negative 4. So what are some factors of negative 4 that would add up to 3? How about negative 1 times 4? So I can pull apart that middle term. So I still have my 8y on the outside over here. Guess I needed more room than I thought. 2y squared plus 4y minus y minus 2. And then I can factor by grouping. 8y times the greatest common factor of 2y squared and 4y is 2y. That just gives me 1y plus 2. The greatest common factor of negative y and negative 2 is a negative 1. So why don't we go over here? So I've got my 8y on the outside, and then remember I collect my greatest common factors and multiply that by what's remaining, which is y plus 2. And that would be number 1 fully factored. Let's go ahead and make a little bit more room for number 2. We can do that by zooming in. So I've got negative 3x squared plus 9x minus 6. Well, remember I want to pull out the greatest common factor, and I don't want a negative leading coefficient, so I'm going to have negative 3 times x squared minus 3x plus 2. So I want to find the factors of AC that add up to B. So what are some factors of 2 that add up to negative 3? Well, that'd be negative 2 times negative 1. That gives me negative 3 x squared minus 2x minus x plus 2. And then I factor by grouping. Negative 3 times x minus 2. Here I pull out a factor of negative 1. I collect my greatest common factors and what they had in common. Our last example, I have 8y cubed minus 12y squared plus 4y. I look for the greatest common factor of my coefficients, that's going to be a 4. The greatest common factor of my variables, that's going to be a y. So I have pulled out a factor of 4y, that gives me 2y squared minus 3y plus 1. So I say, okay, what are some factors of AC, which is 2, that add up to B, which is negative 3? And we've already done that, right? We found that it was negative 2 and negative 1. So I've got 4y, 2y squared minus 2y minus y plus 1. And then I can factor by grouping. I still have my 4y on the outside. The greatest common factor of 2y squared and 2y is 2y. The greatest common factor of negative y and 1 is, remember, we don't want a negative leading coefficient, so it's negative 1. I collect my greatest common factors, so I have 4y times 2y minus 1 times y minus 1. And And that would be this example fully factored.